Containers, the foundation of modern web applications. So we talk about containers, they fit in the same bucket as microservices. If we talk about microservices and containers, we have to talk about how do we orchestrate all these containers together. Then how do we balance out the connections going to all these different servers we just created? And how do we deploy all that? Again, this is its own complex field, and we're going to cover it in a few minutes. So we're going to be just enough to be dangerous. Most of you have probably heard of the microservice architecture. It's a software architecture of loosely connected services. The opposite of the microservice architecture is the monolith. That's just one giant PHP file or one giant PHP repo, or Python and Django is usually a popular one. You can do everything in Django. Or you can have a mix of both. You can have a monolith that connects to a bunch of microservices, things like that. The picture on the left is an old demo of someone made at Netflix during a hack day, showing all of our microservices connected. This is many years out of date. So you see the complexity of way over here is the internet. About here is where my team owns, which is Netflix.com. And it's really small. The names don't mean anything. They're just gibberish. But like, that's just the surface level. And as UI engineers, we usually stay about here, when in reality, we're learning through this course that there's a whole lot behind the things we do that we count on. The pros and cons of microservices versus monolith. Monolith, it's easy to work in. It's one language generally. Everybody can work in the same repo. You know what everybody else is doing. There's not going to be any merge conflicts generally, because you're all working in the same file system, same repo. The pros of microservices are, I can write a React application, you can write an Angular application, someone can write an application in Java or Groovy, and we don't have to talk to each other at all. We can write applications in our own specialty. The downside of microservices is coordination. If everybody's writing their own services in their own languages with their own idea about what the API should look like, how do we get each other to talk to, or how do we talk to each other in a way that makes sense? So there's a trade-off. It's that, like we said, Netflix, freedom and responsibility. The same applies for microservices. You have the freedom, but you're responsible for connecting to your partners as well. So I won't say which one is better or the other. We see microservices becoming more and more popular because they're easier to reason about. We can have people at different levels of expertise. However, you do have to manage the microservices. So there's no one size fits all. The way we are able to create microservices is we use something called containerization. Similar to the concept of virtualization, but virtualization is slicing up a server specifically into these chunks, these distinct parts. Just like we bought our own VPS, virtual private server, hence virtualization. Container goes a little bit farther, and it says, hey, what if you have a service? And we're just like, this is just like our service here, except we're only using a slice of it. And we're using Node.js, MySQL, Nginx, or we're not using MySQL, SQLite. But this is all one server. But what if instead of that, what if we just broke it up into each of these is its own microservice, its own container? So now, instead of our server just running Node.js and Nginx in one block, it would just run a container that has Node.js, our application. And Nginx is an entirely different application. That allows us to, say, update different things at different times, allows different people to work on different things without interrupting the whole system. Just like every time we updated our Nginx configuration, we had to restart the system, which takes us down for a few seconds at a time. What if we can get around that by having a container with Nginx running? We update half the containers, the other half stay up and running. Then when they're all updated, we just switch traffic over really quickly. And that way there's zero downtime. And these are kind of newish concepts in the world of software engineering, like zero downtime and containerizations, things like that. And really containers are the core, besides virtualization, of cloud computing. Because now I can buy these VPSs, I can buy these chunks of a server that are running chunks of an application at a time. It allows us to scale out really, really well. And for a lot of people, it's hard to kind of wrap your head around this, like why would we need containers and virtualization? But remember somewhere like, where I work at Netflix, we're running thousands of containers just for our website. And we're running thousands of instances of our databases. And you scale all that out, it gets really, really complex. But it's so much more efficient than me creating 100 Ubuntu servers and setting them all up manually and doing the whole thing we just went through in the past couple lessons. That would be a lot of work. Why don't we just wrap it all up in instructions, and that way we have some layer that says it doesn't matter what operating system you're running on, your program's always going to work because it's just this tiny little container. And that's what we're going to do today. We're going to create a container. And the great thing about containers are they don't care about what operating system you're running on. So yeah, we're running on Ubuntu right now, but what if I want to run on OS X? What if I want to run on a Red Hat or Fedora or something like that? Containers can run on anywhere because they're operating system agnostic. It's up to that parsing layer. And for our instances, we use Docker. Docker's the big one you've probably all heard of when it comes to container management. There's also Amazon ECS, Apache Mesos, CoreOSKit, et cetera. There's a lot of different solutions these days. And I touched on this earlier, but containers are super lightweight. They only run the application that you need, nothing else, no other fluff. They're portable. We can move them around from OS to OS. They're much easier for development because you can just download my container image and you get up and running very, very quickly. They're easy to manage because I think as we saw when we implemented WebSockets and databases, the more things you have put together, the more chances something is going to go wrong. So if you're only running one application, it's a lot easier to reason about when something breaks. They're faster to start up because, again, it's only that application. And most importantly, we decouple the application from the infrastructure, which is really important. I've talked a lot about the paved road and saying we're using Ubuntu and Nginx, and we're following this really tight path, which makes it easy for us to use other tools. But what if we can just decouple all that entirely so it doesn't matter what the underlying infrastructure is, what our operating system is? We can just write applications that run anywhere. That's why containers are really, really awesome.